All right, here we go. A rectangular garden, 32 square feet in area, is to be fenced off against rodents. Find the dimensions that will require the least amount of fencing if one side of the garden is already protected by a barn. All right, so draw. Here's your barn. This is a barn, guys. It's an aerial view. And here's the fence. How many square feet do I have? 32 square feet. So that is my restriction equation. So I'm going to say, if I call this x and I call this y, I'm going to say x times y is 32 because area of a rectangle is length times width. Are we okay? All right, so there's my restriction, and they want me to optimize the least amount of fencing. So that the amount of fencing is, let's see, f for fence and x plus 2y. Does that make sense? Okay. I'm going to divide both sides by x for my restriction equation so I can get my f in terms of just one variable. So y equals 32 over x. That's what I'm going to plug in that's what I'm going to substitute in for y. X plus 2 times 32 over x. If I double 32, I believe that's 64. So f equals x plus 64 over x. Side note, by now we should already be pretty good about just taking the derivative of that, but just side note that that's 64x to the negative 1. Here we go, guys. I'm taking the derivative. F prime. Chav, why are you taking the derivative? Because I'm trying to minimize this. Remember that, okay, this is just a side note. Remember that minimums and maximums happen whenever you have a horizontal tangent. So the game plan is that I'm going to take a derivative and I'm going to equal it to 0 because these are critical numbers where I have max and mins. Does that make sense? Okay. If you were to graph your derivative, you would be crossing the x-axis from negative to positive at that x value that we're about to get. All right, here we go. Derivative of x, 1. Derivative of 64 over x, that's going to be a negative 64 x to negative 2, so over x squared. I'm going to equal this to 0. Is everyone okay with that? I'm going to move that 64 over x squared to the right. So 1 equals 64 over x squared. Multiply both sides by x squared times x squared times x squared. X squared equals 64. And I'm going to take a what? Square root. X equals 8. Now that I have x, I can figure out y. Plug in x equals 8 into the 32 over x. So y equals 32 over 8. And sure enough, that is 4. Sorry, there's a little sugar ant in my little screen here. All right, there it is, guys. 8 by 4. 8 by 4. In case for child, you didn't do any testing to see it really goes from negative to positive. It does. If you were to type this into y1, you would cross the x-axis at x equals 8, and it would be from negative to positive. If you choose a number smaller than 8, when you square that, 1 minus whatever this is would have, right? Do you guys see that? Like if I chose 1 squared is 1, 64 over 1 is 1, 1 minus 64, that's negative. See, and if you choose a number bigger than 10, the 64 over 10 squared, that's 100. 1 minus that is going to be positive. So you do, in fact, the derivative does change negative to positive at x equals 8. Cool or not cool, guys? Cool. All right, here we go. Find the largest possible area for a rectangle with base on the x-axis and the upper vertices on the curve. All right, so this is kind of like what you did yesterday. Here's your curve, or that's the x-axis, not the curve. Here's the y-axis. And I'm just going to exaggerate 9 minus x squared. I'm going to say it looks like something like that, because it does, right? These coordinates way over here is negative 3 and 3. X has to be a value between 0 and 3. So that's how I know that whatever value I get, it's going to have to be a max. Chop, what's your x? The distance from the origin to that value. That's an x. Let me erase that. Oh. Why the sign, miss? Oh. Here is your rectangle. This distance is x. That distance is some x value. They want the largest possible area, right? Area equals 2x, that's my width of that rectangle, times my height, which is y. Well, y is dictated by 9 minus x squared. So 2x times 9 minus x squared. Is anyone confused with that expression? Let me know, guys. All I'm doing is 2x times y because this is what the height of that rectangle is. All right, here we go. Distribute. Area equals 18x minus 2x cubed. I don't see any mistakes. Let me know if I do. I'm going to take a derivative. A prime equals 18 minus 6x squared. I'm going to equal my derivative to 0 because I know that maxes and mins happen where the derivative is 0. And since I have a restriction between 0 and 3, I know that whatever critical number I get, that's a max. 18 equals 6x squared. Divide both sides by 6. X squared equals 6, 12, 18, 3. X equals square root of 3. There it is. They don't want the x value. Good thing they don't put square root of 3 in there to try to trick you. They want the largest area. Just insert it right. Bam. Bam. Just insert it there. Area, maximum area is 18 times square root of 3 minus 2 times square root of 3 raised to the third. Child, I need a calculator. Relax. Let's go slow. 18 times square root of 3 is just that. Minus, I'm going to leave the 2 for now in there. Square root of 3 times square root of 3 times square root of 3. I guess I'll write it in so let's not make any mistakes. Square root of 3 times square root of 3 is just 3. What's 2 times 3? So I have 18 square root of 3 minus 6 square root of 3. Well, that is just 12 square root of 3. Yay. Are you not entertained? All right. Sorry, guys. Do you guys know that came from a movie? From the movie Gladiator? Oh, I don't know. Okay. Okay. Thank you. Of all the rectangles in an area of 25 square feet, find the dimension of the one with the smallest perimeter. If you know enough geometry, you know that that's going to be a square. But if you don't know that, then pretend you don't know that. So here we go. So here is a rectangle. And that's what they tell me. It's a rectangle, right? And I'm going to call this X. I'm going to call this X. And I'm going to call this Y. And I'm going to call this Y. Charles, why do you call that X, X, and the Y, Y? Anything that's horizontal, I'm going to call X. Anything that's vertical, I'm going to call Y. How much area do I have? So that's my restriction. So I'm going to say X times Y equals 25. How do I get perimeter? Yep. I use P for the word perimeter. I want my perimeter equation with one variable, not two. So I just use my restriction. I divide by X, divide by X. You don't have to divide by X. You can have everything in terms of Y if you wanted to. So there it is. Y equals 25 over X. I plug that in here. So my perimeter equation is 2X plus 2 times 25 over X. And then I just distribute, right? Distribute the 2 times 25. 2X plus 50 over X. Now I'm going to take a derivative. P prime equals 2. Remember, that's 50x is negative 1. Negative 1 times 50 is a negative 50. And then I'm going to subtract 1. So that's x is a negative 2, which is the same thing as saying, and I'm going to equal that derivative to 0. Now it becomes a game of algebra, kind of. So you just move the 50 over x squared to the right. 2 equals 50 over x squared. Times x squared times x squared. I'm going to get 2x squared equals 50. Divide both sides by 2. X squared equals 25. And then finally I take a square root. X equals 5. Chop, how did you know that y is 5? Well, y is 25 over x. Plug in that 5 in for that x right there. So y equals 25 over 5, which is also 5. And it's not a shocker. If you're really good at geometry, it's not a shock that you get a square fencing for lowest amount of fencing. How do we feel? Magia, you doing all right? Okay. Let me know, guys. Let me know. All right, here we go. Of all the rectangles with a perimeter of 84, find the dimensions of the one with the largest area. And it's no coincidence that notice it's a 21 by 21, but I don't want you to be I do want you to be good test takers, but don't cheat the system. Like, do it the right way, you know? All right. No. All right, here we go. I have a rectangle because they're telling me that I have a rectangle. And x, x, y, y. And I have this time the perimeter is 85. So I'm going to write 2x plus 2y equals 84 feet. And this time I'm trying to optimize the area. So area equals x times y. So I'm going to move this 2x to the right. So 2y equals 84 minus 2x. Divide by 2, divide by 2, divide by 2. Y equals, what's 84 divided by 2? 842 minus x. All right, plug this guy in here. So my area equals x times 42 minus x. Distribute the x. Area equals 42x minus x squared. That's what I'm trying to maximize. That's what I'm going to take a derivative of. A prime equals 42 minus 2x equals that sucker to 0. Move the 2x. 42 equals 2x. Divide by 2. X equals 21. Once I know what x is, plug it in here to get your y value. Y is equal to 42 minus 21, and you get another 21 again. So 21 by 21. And you notice a pattern. Can we take some more? All right, now notice these aren't squares. 110 by 70, 90 by 90. I don't know. Maybe by now you might think that because, see, notice this one's not a square. Let's see what the question says. A rectangular playground is to be fenced off and divided into two parts by a fence parallel to one side of the playground. Yep, you're changing the game. You're changing the equation. 360 feet of fencing is used, and we're going to use that. The partition is also, the fencing is also used for the partition, guys. Sometimes they're not good with their words, but that it is. Find the dimensions of the playground that will enclose the greatest total area. Okay, here you go. Here is my enclosure, and you are using your fence to also do the partition. That's also part of the fencing that you have. Does that make sense? So x, x, y, y, y. Shaw, what happens if you reverse the order? What if I had a long one and you'll get the same answer, just your x will be a y and your y will be an x, like your answers when you get them. You know what I mean? So as long as you do it the right way, you will get the same answer. All right. I have how much fencing? So I'm going to write 2x plus 3y equals 360 feet. And I know that my maximum area, regardless of that partition, is x times y. Cool or not cool? All right, move the 2x to the right of your restriction equation because I'm trying to get my area in terms of one equation. 3y equals 360 minus 2x. Divide everything by 3. Y equals 3 goes into 36 12 times, so that has to be 120 minus 2/3 x. I don't see any issue. I don't see any mistakes. I'm going to go to area, and I'm going to plug that in. X times 120 minus 2/3 x. Distribute the x. Area is 120x minus 2/3 x squared. I am ready to take a derivative. Sorry. A prime, that is actually code dir for derivative in some programs. So here we go. Derivative of 120x is 120. And derivative of 2/3 x squared is 4/3 x. Equal that sucker to 0. Don't become a robot. It's very easy to become a robot. Why are we equaling it to 0? Max and mins happen at 0 when the derivative is 0. Move the negative 4/3 x to the right. So 120 equals, let me erase that y so you guys don't think that's equals y. Equals 4/3 x. Multiplied by the reciprocal. Times 3/4 times 3/4. X equals, let's see, 4 goes into 12 3 times, so 30. 30 times 3, 90. X equals 90. X equals 90. Get your Y value, because they wanted the dimensions. This is find the dimensions, guys. Get your Y value. Where's my Y? Over here. Plug it in right there. So Y value is 120 minus 2/3 of 90. I like to do it like this. 3 goes into 9 3 times, so 3 goes into 90 30 times. 2 times 30 is 60, and 120 minus 60 is 60. So 90 by 60 with a divider that is 60 feet long. There it is. Yeah. It's a good song. Are you ready? Oh. All right. Check it out, guys. Find a and b given that the function y equals a over square root of x plus b squared of x has a minimum value of 6 at x equals 1. Create a system of equations. First, you know that when x is 1, what's the output? So let's do that. 6 equals a over square root of 1 plus b square root of 1. So my first equation is just 6 equals a plus b. I don't know, circle it. That's your first equation. Now I need a second equation. Well, I know that I have a minimum when x is 1, so that means that my derivative is 0 when x is 1. Child, why? I don't understand. Because at minimums, guys, you have a critical number there. Your horizontal tangent is 0. See? So at max and mins, you have tangent slopes that are 0. So I'm going to take my derivative and I'm going to equal it to 0 when x is 1. Does that make sense? Okay, I'll say it again. Guys, minimums and maximums happen, not only do they happen at when your horizontal tangent is 0, but they also happen when you're undefined. See, look, boop, that's like a corner. So you set your derivative equal to either 0 or undefined. In this case, we're going to set it equal to 0. Say it again. Why would we do 6 equals b? Oh, because I know that I have a minimum value of 6 when x is 1, so I plugged in a 1 and I equaled it to 6. Because that was given. You know what I mean? All right, here we go, guys. This is a, just rewrite it, ax to the negative half. And this is bx to the half. So here we go. Y prime equals negative half times a, negative 1/2 a, x to the negative 3/2, plus 1/2 b, x to the negative half. How do we get what? Yeah, just took a derivative of this expression of y. Ask me, miss. Ask me. But didn't we just made an equation? No, they gave me the equation. But like we made the equation from the equation. Oh yeah, we to find a and b. Yeah, we need to have two. In order you have two unknowns, you need to have two equations. Yeah, we don't have fancy Monte Carlo software where you can make predictions based off of limited information, because we're not there yet. Because now we'll have two equations. This will be my second equation. Look. What is this equation? Because we know it has a minimum value. Yeah. So the derivative is 0. So I just go 0 equals negative a over 2 square root of 1 cubed plus b over 2 square root of 1. So my second equation is 0 equals negative half a plus half b. Yeah, you see division? I see it. Move the negative half a to the left. 1/2 a equals 1/2 b. I'm really tempted to just delete the half, but I want to show you guys everything. Because times 2 times 2. Whatever you do to one side, do to the other. Bam, bam. A equals b. Chav, how does that help me? Now that, relax. Look, guys, now that you know that a equals b, you can plug it into whichever letter is your favorite. Since you guys all love a's, we'll plug it into the a. So I'm going to write 6 equals A equals B. So I'm going to write B plus B. So 6 equals 2B. So what is B? 3. And since B is 3, A has to also be 3. And there it is. No, don't say it's a square this time. I mean, I guess if you want to put vertices on A and B or something, but no. Or dimensions on A and B. No, A is 3, B is 3. There it is. That's the equation. All right, let's go to the next one. So ask. Okay, while you do that, I'm going to drink some of my Dr. Pepper.
We said the x is 1 because that's what we did with the right?
They give you that. They give you x is 1. Right? It says right there, minimum value of 6 when x is 1. Yeah? Yeah, usually we're looking for that. But
what do we call the second equation? Is it the one,
y
prime? Or is
the
it
y prime.
Okay.
The y prime is my second equation, and then I plugged in x equals 1.
Oh, okay. That part too. Yeah, you're trying to show us the second step, but in my head, I was like, I thought you were it was just...
Okay, ready for the next one? All right, guys, here's our hack. Oh, actually, this one, okay. If you're a robot, I need everyone's attention for this one because this one will get you. If you're a robot, you might see there's 2 options. You know what? Let's do it first so you can see what some of you guys might pick if you're a robot. So it says, find the coordinates of the points on the curve that are closest to the origin. Everyone knows that the origin means 0, 0, right? So put it in there. Hopefully we know that. If I divide all this sucker by 2, I get an equation that it says y equals 12 divided by 2, 6 minus 1 half x squared. So I have a parabola opening downward, kind of fat. Can I say that? That's not like, we're not offending anyone, right? Like, I'm a big guy. So yeah, it's just a curve. And they want to know what segment. They want to know what segment. Is it this segment? Is it this one? Is it that one? Well, it's symmetric. So if you found this one, then this one's going to be the same. So you're going to have 2 answers. So I guess immediately you can just delete A and B because it's symmetric on the y-axis. And D. I guess it's between C and E. I guess if you really think about it for a long time, you can probably just guess the correct answer. All right. I want to figure that out. I want to figure the smallest value of segment D. Yay or nay? I know that the distance formula is this, so I'm going to write it over here, guys, the distance formula. D squared equals change in x squared plus change in y squared. It's just Pythagorean theorem. And then if I take a square root for D squared, so here it is. But remember what we told you yesterday about the hack. Okay, I'm going to slow down. I want this segment to be the smallest possible. You will get the right answer if you do chain rule with the square root. But why do you want to make life harder for yourself? So just delete the square root because remember, what am I looking for? I'm looking for where this is the smallest. Well, this is the smallest whenever this expression on the inside is the smallest. Yes or no? So just delete the square root symbol. That's the hack. That's the hack. So hack, just delete the square root symbol. Hack. You'll get the right answer even if you keep the square root. You're just making life hard. So I'm going to say, here's my equations. The change in x squared plus the change in y squared. Here we go, guys. This coordinate, that's just some x. What's the y coordinate? The y coordinate is just 6 minus 1 half x squared. Because that's what y is. Why is that? Are we still okay? Chav, why do you choose quadrant 1 and not quadrant 2? It doesn't matter, guys. I always like to work with quadrant 1 because it's the easiest. It's symmetric about the y-axis, so we're going to get the plus minus. All right, here we go. D equals the change in x. So x minus 0 squared plus the change in y. 6 minus 1 half x squared minus 0 squared. The 0 and the 0 is the origin. I guess you didn't need it, but that's fine. All I did was x2 plus x2 minus x1, and then y2 minus y1, and I'm squaring both. Because that's what it is, right? Changing the x, changing y. No one's scared? You okay? Yeah, all I'm doing is changing x minus 0, and then changing y. That's your y2 minus 0. So 6 minus 1 half x squared minus 0. And then it doesn't matter because the 0 is there, it goes away. All right, here we go. D equals x minus 0 is just x. I square it. You just want to take the derivative immediately? Why do we not know? Go ahead and ask. Well, that's the change in y. You know what I mean? Yeah, x minus 0 is just x. And I guess you could do chain rule here, guys, but I would just, I think it's easier if we just expand it, or I don't know. What do you think it's easier? Just take a derivative immediately? Okay, let's take a derivative immediately. Plus 6 minus 1 half x squared close to 2. Here it is, d prime. 2x. This is Chavez. Hey, Ms. Watson. Yes. Okay. Mm-hmm. Hey, Ms. Montanez. Ms. Watson wants to see you. All right, here we go. I'm taking the derivative, guys. Plus 2, 6 minus 1 half x squared closed times the derivative of that inside, negative x. Should be easy enough. Let's see. D prime equals 2x. Let's see. 2 times negative x, 2x. So negative 12x and minus x cubed. Did I do that right? Check my work, guys. Plus. Good job. Let's see. Everything else check out? Yep, everything checks out, guys. So combined like terms, negative 10x plus x cubed equals 0. I'm going to factor out an x. Negative 10 plus x squared equals 0. So let's set the inside there equal to 0, right? Negative 10. What happened, miss? Equals 0. Move the negative 10. X squared equals 10. X equals plus minus square root of 10. 2 times 6. Right here. You can combine these if you want, miss, to make it easier. 2x, 6 minus 1 half x squared, and then distribute like that. If you think that's easier. Well, negative, I guess.
You're right. I don't know why I had it.
Yeah. Here we go. All right, guys. Do you see this answer on the outside? X equals 0. Some of you would get tricked, and you would choose letter C. Look what the question is saying. Closest. So here's what you do. If I plugged in, guys, I need your A game real quick. If I plugged in x equals 0, I would be the segment I would be in this segment right here in green. I already know where that vertex of that parabola is. That vertex of that parabola is at 0, 6. So what's that segment in green? What's the length of that segment? 6. And then you're like, okay, well, that's that one. Let's see what this segment is. This one says plus or minus square root of 10. If I plug that in here, what is this segment? Well, let's see. The x value is square root of 10. That's this x value here. And then the y value would be square root of 10 squared is 10. 10 half of 10 is 5. And 6 minus, yeah, you're right. 6 minus 5 is 1. So this distance here would be a 1. Do you guys see that? And you're saying like, Chav, I still don't understand what's going on here. I'm finding this distance here. So if this is square root of 10 and this is 1, square root of 10 squared is 10 plus 1 is 11. And then this distance will be the square root of 11. Maybe I did more work than necessary. I don't know. Okay, I'll start again, just in case. Pythagorean theorem. I did Pythagorean theorem. That this distance is square root of 10. This distance is 1. And the Pythagorean theorem to get this distance, 10 plus 1 is 11. That's square root of 11. Well, what's smaller? Square root of 11 or 6? Square root of 11. So, you're not going to choose the answer with 0, 6. They tried to trick you. It's just this one. because this segment here has a length of 6. Do you guys see that? I think that's the only one that they try and trick you. I know a lot of kids that get 90s or that miss questions. Now, don't cheat the system, guys. Maybe I shouldn't have made you aware of that, but there it is. So what's the answer? That one. How do we feel? Don't worry, guys. We're almost done. These next 3 are not too extreme, except for the last one. Question 8. That one's similar to the one in your notes, but do you guys want me to do it or no? Okay. So here it is. Here's my scale, or my grid, sorry. And the square root of x plus 3 is like somewhere here, -3. And it says closest to the 0.60, not to scale. Sorry. That's 0.60, and they're looking for this. Is that the shortest? Is this the shortest? Is this the shortest? See? Again, I'm doing the hack. So this coordinate is just some x value. And what's my y value? Square root of x plus 3. So maybe this is actually, it's supposed to be harder, right? Because it's question 8. But it's actually easier. I'm just doing my hack, guys. Here's my hack. Distance equals the change in x. So I'm going to call, it doesn't matter. X minus 6 close it squared. Plus the change in y. This y value is 0. This y value is square root of x plus 3. So square root of x plus 3 minus 0. Close it squared. All right. D equals x times x is x squared. I'm just expanding it. X times -6 is -6, but I'm going to have 2 of those. So -12x plus 36 plus x plus 3. Because the square root of x plus 3 minus 0 is square root of x plus 3. When I square it, the square root goes away. Yeah, I know. It's cumbersome. It's a lot of algebra. X squared minus 11x. Let me know if I make mistakes, because I make mistakes all the time. Plus 39. All right, I'm just going to take a derivative and equal it to 0. What? 2x minus 11. I heard someone say something. 2x equals 11. There it is. X equals 11 over 2. Out, out, maybe, out, out. There it is. In case you're wondering, Chop, how do I get that y value? Plug in the 11 over 2 in there, because they want a point on the curve.
Oh.
Oh, yeah. I didn't do any linkage error, did I? No. Oh. Yeah, that's what you got to tell me. I didn't put prime.
Is the reason why we don't put the x at the bottom? Can we take distance for this? The reason we don't put x at the bottom because equal it to 0, just to cancel it out anyways.
If I were to do x, yeah, that would be bad. It's a curve. What are you saying? Say it again.
Aren't we doing distance?
Yeah, we're doing distance.
But it has like x2 minus x1 at the bottom.
Yeah.
But the reason we don't include it is because we're eventually going to equal it to 0 anyways, right?
We are going to equal it to 0, yes.
Okay. I was wondering why we weren't including it.
X2 minus x1. Well, this x1 is 6, right? And this.
But if you put 6, it eventually just equals 0 because you have to multiply it, right?
I'm not sure if I understand your question. All I'm doing is, yeah. Okay. Yeah. Change in x squared plus change in y squared. This is like my x2, quote unquote. And this is like my x1. So x minus 6, and this is like my y2, quote unquote. And this is like your y1, so square root of x plus 3 minus 0. Okay. All right, guys. Sorry. Hopefully, I didn't confuse you guys too much. Here we go. A rectangle has one side on the x-axis, and the upper 2 vertices on the graph y equals 4 e to the negative x squared. Where should the vertices be placed so as to maximize the area of the rectangle? All right. First and foremost, all right, guys, Ms. Conduro, focus. Don't worry about the kid. I know YouTube might think that no, it's a fake kid, guys. It's a fake kid, YouTube. All right, here it is. I believe it looks something like this. Dang it. Let me draw it better. It looks something like this. All right, here's my rectangle. It's a metric about the what? Y-axis. So that means this distance that you see in green, from here to here, that is just x. Do they want the maximum area or do they want the vertices? They want the vertices. Okay. The vertices that make the max area. All right, so here's my area, guys. Area is 2x times y. Does everyone know where I got the 2x? This distance here is x. So the distance from here to here is 2x. Does that make sense? Okay. The y value is this guy. So my area is 2x times 4e to the negative x squared. So those are parentheses there. So my final area, 4 times 2, I don't see any issues. 8xe to the negative x squared. There's my area formula. I'm trying to maximize area, so that's what I'm going to take a derivative of. And this time I won't do any linkage errors. I'm going to call it a prime. First, times derivative of the second, e to the negative x squared times negative 2x, plus second, times derivative of the first. Let's go ahead and simplify this so it looks easier. I almost put an x in there. We're going to factor out an 8e to the negative x squared. And that's going to give me 2x, negative 2x, plus 1. I don't want to. Oh, guys, look, I almost made a mistake. There's an x here and there's an x there, so this one should be squared. Now we're good. Yeah, we would have gone to an answer. We would have been like, our answer is not in there, so good thing we put that square there. Okay, that's it, guys. We're done. This will never be 0. Never 0. But this will. 2x, negative 2x squared plus 1. I was just going to take a shortcut and just go right into it. But move the 1 to the other side. Negative 2x squared equals negative 1. Divide by negative 2. Negative divided by negative is a positive. And then square root. X equals 1 over square root of 2. Law of exponents. Multiply by square root of 2 over square root of 2. And you get square root of 2 over 2 plus minus. What happened, Kunduru?
How do we move that to the other side? Aren't they multiplied to each other?
No, there's a plus in the middle. Right here. I'm setting this expression equal to 0.
What?
Say it again, Lopez. Nothing. It's never 0.
So you can't have a critical.
It has a limit, but the expression itself, 8e to the negative x squared, will never be 0. It doesn't matter. Yeah, you'll never have a critical number from it. If you're wondering, okay, check it out, guys. Maybe out, because both of these are negative, see? So it's between A and B. So how do you find the y value? Plug this guy into the x squared. Y equals 4e negative parenthesis square root of 2 over 2 squared. So let's see what that is. 4e negative on the outside. Square root of 2 times square root of 2 is 2. 2 times 2 is 4, so that's 2/4. But 2/4 reduces to 1/2. They were being nice. They could have easily done this 4 over the square root of e, but they didn't. To the original, because they want vertices, miss. It says right here, where should the vertices be placed? So it needs to be on the curve. It needs to be on the curve. Look, I'm going to use my laser. It needs to be on the curve. So this guy, it needs to be on this curve. So this is my curve. No, ask, miss. I'm sure others had the same question. All right. This is the toughest one. It's going to require your full attention, guys. I think it's because of one word. They should have used the word, in my opinion, I don't know, that's just my opinion, perimeter. Circumference is only for something that's always circular. Let's read the question, and I'm going to go as slow as I can, and please stop me. The figure below shows a region that consists of a semicircle on top of a rectangle. Give the value of x that maximizes the area. So what do they want to maximize? The area of the region if the perimeter of the region is 5. So what is the perimeter? Everything that you see that's bolded. So this is x. I'm going to call this, it's vertical. I'm going to call that y. I'm going to call that y. And I need the arc length or the semi-circumference or half circumference of that circle. Do you guys see that? Okay, so here we go. They already tell you what the perimeter is. What's the perimeter? So P equals x plus 2y plus, okay, how am I going to find the half circumference of that? Well, yeah, the radius, right? So first and foremost, let me write a little circle here. Circumference is 2 pi r. But if you have half a circle, it's just pi r. Or I guess I should use arc length, but that's fine, pi r. Okay, so this distance here, we're not going to call it, that's your diameter. That distance there in purple, that's x. So my radius is x over 2. Does that make sense? No? Yeah. Because I want half of that. This is diameter. I don't want all of it. I just want half of it. Right? Okay. So yeah, we're pushing you guys today. Hopefully we're challenging you guys. All right, here we go. So what is the circumference, or I guess half the circumference, or half of that? What's going to be pi times x over 2. And all this equals what? 5. All right, so let's make this pretty first. No. What do I want to maximize? Area. What's area? X times y plus, and this is area of a circle. I'll write it right here. Area is pi r squared, but area of a semicircle is pi r squared divided by 2. So I'm going to write area is xy plus pi parenthesis x over 2 close it squared divided by 2. All right, you guys ready? Let's use the restriction equation to get rid of, I want to get rid of this y here. So I'm going to use my restriction equation to solve for y. So I'm going to write it like this. So who cares about that p, right? Goes away. So I'm going to move everything to the right except for the 2y. So 2y equals 5 minus x minus pi x over 2. Have I confused anyone? Okay, now I'm going to divide everything by 2. Y equals 5 over 2 minus x over 2 minus pi x over 4. I divided everything by 2, guys. This is when I'm going to insert in here. So I'm going to go to the next page because I have a lot of space. And I'm going to slow down. Yeah, I know. If you don't want, guys, I'm recording, so if you just want to take this in, you can just, observe so you can see what's up. Area equals x times y, which is this expression, 5 halves minus x over 2 minus pi x over 4. Make sure there's no errors. Let's see, minus Divide by 2. Yeah, we're good. We're good. And then plus, when I square this, x times x is x squared, and 2 times 2 is 4, and 4 times 2 is 8. So plus pi x squared over 8. Is everyone okay with the pi x squared over 8? Yeah, check it out, Kanduru. I squared this guy. X times x is x squared. 2 times 2 is 4. Keep, change, flip. Right. So 4 times 2 is 8, or yeah, move the 4 down, move the 2 up, whoever taught you math. Are we still okay, guys? Okay, I'm going to distribute this x. That way we don't have to do product rule there. So 5/2 x minus x squared over 2 minus pi x squared over 4. I could do common denominator, but I don't want to do it yet. I don't see any issues. I think we're okay. This is what I want to maximize. This is what I'm going to take a derivative of. That make sense? What are they looking for? I already forgot what they're looking for. Give the value of x that maximizes the area. Okay, they want the value of x that gives me the biggest area. So here we go. I already got everything in terms of x. A prime equals 5/2 minus 2x over 2, so that's just going to be x, minus 2 pi x over 4. 2 goes into 4 how many times? So pi x over 2 plus 2 pi x over 8. 2 goes into 8 how many times? So pi x over 4. I'm going to equal this to what? 0. Let's see. What am I going to do first? I'm going to move the 5/2 to the right because I want all the x's on the left. And I'm going to write the pi x over 4. No, it doesn't matter because I'm going to change the signs right now. X minus pi x over 2 plus pi x over 4 equals negative 5/2. Yeah, this is all algebra. There was only one piece of calculus. I was just taking the derivative, and everything else is algebra. All right. Now I'm going to go ahead and do common denominator. I'm going to multiply this sucker by 4 over 4, this one by 2 over 2, and that one I'm going to leave alone because it's already a 4. So I'm going to have negative 4x over 4 minus 2 pi x over 4 plus pi x over 4. I don't see any issue right now. I think we're okay. Equals negative 5/2. Let's see. Negative 4x minus 2 pi x plus pi x, all this is over 4, equals negative 5/2. Are we still okay, guys? We still okay? Times 4. That negative is floating. I shouldn't have it floating. That's in front of that right there. Times 4. Whatever I do to one side, I do to the other. So I have negative 4x minus 2 pi x plus pi x equals 2 goes into 4 twice equals negative 10. I'm going to factor out an x. Oh well. Negative 4 minus 2 pi plus pi. So I'm going to say minus pi. Equals negative 10. And then what's my last move? Yeah, divide it. X equals negative 10 over negative 4 minus pi. All right, let me factor out a negative in the bottom. Negative 10, factor out a negative, 4 plus pi. Negative divided by negative is a?
Why is the sign from pi negative?
Why is a what?
The sign from pi negative.
2 pi plus pi.
Oh.
Negative 2 pi plus pi. Is the answer 10 over 4 plus pi? Yeah. What do you guys think?
It makes sense, but my brain is overheating.
Exactly.
My brain
All right, guys. Let me write the attempt date and due date. Don't worry, you have another UH quiz due today, so we're not going to make the attempt date today. The attempt date 01/15. And due, what's today? Tuesday? So we'll be due the 21st when we come back because we don't have school on Monday, right? So it's due by next week. That's plenty of time. I think. And that's it, guys. Let me know if we have questions.